So I'm excited to be here. In this talk, I'm going to tell you when you should decompose monoliths, because there are many talks, people show how to do microservices, but we miss the when, so I'm going to talk about it in this talk. So I'm Kfir, I'm working in Wix for the past 6 years. I see myself as a hands-on developer. And in this job, I don't have much time, so I'm coding at night and weekend and so on. OK, we know about Wix. You have a few. So Wix is a do-yourself website, easy, like drag and drop. This is our editor. Just drag and drop like PowerPoint. What we do more things. We do like things to help you promote your online presence on the web, like application, invoices, restaurants, application, hotels, and so on. Some numbers. So we have 72 million users, which are actually building websites, not the user that go to the website. We store 2 petabytes of data, images, videos, all these kind of things that you want to show on your website. We're 3 data centers on-premise and also in major clouds. We serve 2 billion HTTP requests per day. And we have more than 1,000 people working in Wix. And I'm telling you the numbers because we need to understand how it impacts our microservices. So it all starts 5 years ago when we have dinosaur monolith, which we could not control. It took us ages to deploy a version to production, large life cycle of versioning, and we have downtimes, and we suffer from many things. We couldn't scale the software, we couldn't scale the people. And we make a turnaround in the past 5 years when we have now 200 microservices in production. Just to get the understanding, this is a partial list of the services, our ecosystem on Wix, and it's still growing as we speak. OK, so microservices is trending. I tell you, a month ago, I was speaking in a Scala conference. It was off topic, but I had plenty of people listening. I spoke in Java communities about microservices. It's trending. Everyone wants to do it. That's how we all here. But I want to say something. Microservices are not necessarily small. They have different. You can build big microservice. How do you define if it's small or big? We're going to see today the criteria of when you will decompose your monolith. Microservices has many aspects, which I'm not going to talk about in this talk. We're going to focus only on the when. OK, so I think before you're going to decompose your microservices, you should think, because sometimes less is more. Microservices has trade-off. It's not like magic. I'm going to do microservices, everything's going to work for me, I have deployment, I've scaled the people and everything. It has many trade-offs, and let's go over them. OK, so now you have IOPS. In the old time, you have monoliths. And in the monoliths, a request comes, you do whatever you want to do in the CPU, you go to the database, and that's it. But now, when you got a request, you go to uncertainty mode. When you go out of the network of your box, it leads to uncertainty. You don't know what's happening. You can have problem with DNS. You can have problem with outage of the electricity. Going out to another IOPS increase the risk and reduce your availability. It's different. Partial deployment. So now you have new feature, and you have microservices. Sometimes this feature is being developed on few services. So you need to think how to deploy it, when to open it, and so on. It's a lot complex. In the old time, when you have monolith, just deploy your server, and that's it. Ops. In the old time, when you have monolith, you have your ops guy. They know your server, they know the ops, know to install it. You have a bash script, you have something. It's easy. But now you have hundreds of services. You want to maybe have self-provision for them, and it's very hard, it's complex. You need to somehow automate. And strong interfaces. If, let's say, one service wants to change the interface, in the monolith, you go to your IDE, your IntelliJ, you can press Shift F6, you change the parameters, that's it. But now we have interface between your services, and refactoring and changing their parameter is complex. So you need to think of it, how you're going to do it. And of course, end-to-end testing. Not like running a server and that's it. Now a request comes and have like 7 or 8 I/O hops. How do you do end-to-end testing? How do you do continuous delivery? But for each of those, there is mitigation. So let's go over them. For the I/O hop, you can learn how to configure your HTTP client. You can choose either Apache or async HTTP. You can use reactive like Spray HTTP. You can learn how to configure it properly to have less problems. You can do retry. You know that 90% of problems are solved by the first retry. But if you do retry, you might want to be idempotent, so you don't want to have multiple side effects. For example, let's say a request that goes and do transaction for billing. So if you do multiple retries, you might charge the user a few times, so you want to be idempotent. Of course, you can do also circuit breakers, so you can have more quality of service and decide which server to go to. You can have more monitoring. And sometimes you can also have eventual consistent API. It depends on the client. So you can do many things to resolve these I/O problems. Partial deployment. You have your feature toggle, sometimes call it feature switch. So you deploy the versions, the feature is off, and by click of a button, you can open it partially. You can open it to a sort of a geo, or for a few users, and then open it gradually. And you can do it only after the server are deployed, so it's easy. You can do it. The ops. So now we go into automation. Everything that we did in the monolith manually now should be done automated. Every manual step should be automated. It's a change of a mindset. And also, it's a change of a mindset for developers. Now, developers are in the center. Developers now need to know the ops. Of course, don't need to know how to script that's installed in the server, but they need to know when the server is deployed, they do it themselves, how. Developers now change. In the back days, developers just, OK, take this, install it for me, for the DevOps guy. Now, developers are the owner, also from ops point of view. Strong interface, so we have, you can do back compatibility and forward compatibility, new parameters, you can ignore them, and so on. You need a strong build system. So when your friend is your server, deploy a version, you might want to be failed on the build time. So you can tell him, oh, listen, you broke my interface, and then so on. And you need the proper contact test. So you have a few services, you depend on one of them, you want to have proper tests, so you will fail before you're going to production. OK. So I said we have trade-off. I show you the trade-off. I show you the mitigation. Even though you have all the mitigation, you need to know adding a service, adding a failure point. But let's do microservice. Come on. That's why I'm here. OK, so let's start. Now I'm going to go over with you on 4 criteria why you should decompose your monolith. So the first use case will be an item service, catalog service. So we have, let's say you have an online shop service. You have catalog of items, you have inventory, you have shipping methods, all these kind of things that you have online shop. And this service has 2 kinds of API, the CRUD item, operations for the items, and there is the file upload mechanism. Like, for example, I'm selling T-shirts, so I want to upload the photo of the T-shirt. Everything is working as expected, And one time, I have a network problem going to the file storage. OK, what's happening now? The server threads are busy on I/O. Server not accept any more requests. Client cannot perform critical mission. OK, so now what's happening? Because of uploading a file, which is something in different SLA, uploading a file is something that the site owner, the online shop owner, doing. Because of this, his clients cannot make any purchases. It's crazy. It's different SLA. So what is SLA? SLA is something that's defined by the product guy. We are a developer. We need to ask the product manager, what is the SLA? What it be? SLA can be, I can answer in 10 milliseconds or 20, or this can be virtual consistent, and this should be guaranteed at least once. You need to define, and once you define the SLA, you should have dedicated server with different SLA. You don't want the different SLAs of services or feature will compete on the same resources. And this is the most canonical usage for decomposing your monolith. One story, I worked in an Orange company, and we defined something we call phantom. So when you call someone, you hear music when you call someone. So which music are you going to hear? Music you define to your friend. So on that time that the call is being initiated, there is time to go to database and check what should be played. So the SLA was, OK, give me the answer in 10 milliseconds. Otherwise, give me normal tone. So you need to be careful and need to understand what you do. OK, so let's see what is the solution. It's easy. We decompose a second service, which is the file service. The file service can also get data from the item service. And once we have problem with the network again for uploading the files, customer can still be able to do shop on the store. OK. The second thing is lifecycle. Each microservice has its lifecycle. Let's see. Again, I have the same catalog service. Everything is running. Now I have something called coupons. What is a coupon? Coupons is a feature that lets your product and marketing guys define for specific times. Let's say for Christmas, for Halloween, you can have some coupons and you can increase your sales on this time. OK. Everything is OK. I have my item CRUD, I have my coupons running, and so on. The coupons are changing frequently. Developers go and develop coupons and deploy to production. So let's see what's going on. On 4 p.m., we deploy an item service because I want to add some features for the items. And there is some few coupons because we have sales. So if 5 p.m. a coupon, 6 p.m. a coupon, 9 p.m. a coupon. And then, at 12 a.m., we roll back because we find a bug on the deployment of a 4 p.m. of the item service. And what's happening now? Company loses money. We have two things. We have two features. One feature is like the CRUD of the items, and one feature is my coupons. And they have different life cycle. Now, because of rollback of the service at 12 a.m., I'm losing the functionality of the coupons, which is very bad. So we need to understand the life cycle of the feature that we're going to give to our customers. So in this case, it will be easy. I have a coupon service which is deployed alone and nothing interferes with the item service. It's easy. OK. The next one is decompose to residential logic. Since university, we are avoiding code duplication. We are going and do another function We don't want to have code duplication and repeat ourselves. It also goes with microservices. And let's see an example. A second. OK. Again, we have the same catalog service. And this catalog service has a geo functionality. I want to know where is the customer come from? Where is the city? Where is the map? Where is the country? I want to know it. So by doing this logic, I'm going to Google, get the coordination for the maps. I'm going to a third party. By given IP, it gives me the city and the country. And I have my database for caching and for do more heuristics for it. Everything is working, and it makes sense. Now, the second service, user management service, also wants a geo. OK? So the solution will be easy. Extracting the geo to a search service, and all of them, now we're happy. But it's not trivial. What people do, usually, they say, OK, I have this geo functionality. I wrap it in a jar or a library or whatever. And I'm telling now the other service, use the geo. It's a jar. You can use it. You can use it in your code. And now what's happening? Now two different services sharing the same database and connect to the same database. And we're breaking the rule of microservices. Microservices talk to each other by an interface. And it's very important problem. Another problem we're going to have, let's say now we have 20 services in production using the geo like this. And let's say Google had a problem, a bug. Now I see this error reflecting in 20 services. I cannot handle it properly because this geo has an ops and things to be care of. And if I duplicate it to many services, it's become problematic. So the rule will be that each service must have its own DB. And we talk to the service, not for database. You talk for the service through an interface. I want to show an example when you shouldn't decompose. So let's say service A has a logic of extracting a cookie. Look at the cookie and decrypt it. Service B also needs it. In this case, I want to decompose. I don't want to decompose something that does not have I/O. It's like a computation in memory. It's very precise. I want to decompose and call. I don't want to pay in an I/O hop for something that I do only in memory. So it's not you decompose things that has ops and a database and has files and so on. OK, so the most important thing I want to decompose my monoliths is to have single team responsibility. Do you know that 90% of projects are fail? They fail. You either don't have good content, you might have bugs, and you are late on time. Anyone here can guess what will make it 70%? And I guess someone? No? OK. So, and it's an article that says 3 to 5 developers on a team, 3 to 5 months per project. It's an article, it's science. Small teams make it better. So I'm saying, decompose your monoliths to support organization scalability. Small teams, better efficiency. And large team cannot efficiently handle large code base. You have 100 developers on the same repo, on the same code. It's very hard to maintain. And it does not embrace accountability. Because let's say I'm a developer, and I'm developing this Geo service I showed you before. I have my own domain. I know it. I'm responsible for it. If I'm a one of 100 developers, I don't know how I'm accountable. It's like I'm a developer guy that does features and so on. But we cannot talk about this without mentioning Conway's law. Okay, I'm going to read it. Any organization that designs a system defined broadly will produce design whose structure is a copy of the organization communication structure. And we're saying you need to engineer your HR to get better output of your code. You design and you decompose your teams until you have small teams. It's very important. When you engineer your HR, your organization, you get better output. And this is the most important thing in my talk. You want that your organization will be a corporate in a size, but you want to have a startup-ish culture. Small teams embrace a startup-ish culture. It's very important. And I want to tell you something about Wix. So Wix has moved to a new org chart. We call it guilds and gangs. It's essentially something Spotify does, like tribes and so on. And the guilds and gangs is like gangs are the vertical. So, example, let's say in Wix we have the HTML servers, and we have the restaurant application, the hotel application, and the invoices. All of them are vertical, a cross-functional team. They have client, they have server, they have marketing, they have product, and they work alone. They're totally independent. They're running and doing features. They have one or few microservices, which are totally independent, which, if they need some core functionality, that they use the core microservices easily. And in this case, Wix can scale, and Wix can actually add more products. And let's say, okay, I want to have a team. This team does this. This is going to run. The guilds, it's what I'm doing. It's like the professional, like the horizontal. But we couldn't do this org charts without microservices. This is important. So let's have a recap of what I'm saying so far. First thing, decompose for SLA. Know the SLA. Ask your product the SLA. Know if it's eventually consistent, what is the throughput, what is the response time, how delay I want to have. Ask these questions and try to know the SLA, and then choose on an architecture we want to have. Know the life cycle. How much time it will be deployed. Once a day, every minute. Know the life cycle and choose how you decompose. You will use logic. Decompose things that might other people want and use them as a service. And again, small team is important. Small team with responsibility and accountability. Because I want to feel like in a startup. I want to feel like I'm owner of something. I want to feel like this is my company. In Wix, we call it company. We have small companies. Most important. I have small company, I have microservices, and I'm in a startup, but I'm in a big organization which grows. Okay. So you want to do microservices. I want to give you a few tips, and let's start. Okay. So, make changes gradually. Okay, so you have a system working, everything is okay. Now you want to make the changes. Don't take a day and say, okay, I want to do microservices, take it out. No. Let's take, for example, the Geo functionality. I don't want to now build a Geo service and use it right away. I want to do it gradually. So what I will do, I will take the Geo service, I will build it, another service. I will still have this logic in a jar in my application of the Geo, and I will start move some part of the traffic to the Go service. Only when I'm confident, I will move the traffic there. Okay. If you don't want to lose your job, don't start from your most critical service. You want to start microservices? Take something that no one cares. Let's, for example, I have this item service, the catalog, so I can start with a service that suggests you similar items. If this is fail, of course, you don't like it. But if this is fail, people can still purchase. Do and choose things that not very important, not critical for your business. Confidence builds slowly. So, we're not confident. My boss not confident. My product guys, my marketing guys, they have things work. They have monoliths. Everything is okay. We have services. Yes, we wait for a life cycle of, but they don't. We're not confident of make the change. So we need to talk about it. Talk about the terms and so on. So you create the Geo service. You should talk about it in your meetings with your managers, with your colleagues. Because once you talk about the terms, people start get the sound. And the confidence becomes slowly. And today in Wix, after 5 years or more microservices, now it's like we're all confident and we know what to do. Yes, but we had a bad time, and we have downtime, and deployment freeze, and so on. We need to talk about the terms. Monitoring. So, doing microservices, you shouldn't do everything from day one. Not like circuit breaker and all this fancy stuff. But one thing you shouldn't give up, monitoring. Because now a request comes to a server and might hit 12 other servers. If you have a bug and cascading failure, you wouldn't know how to look at it. So if I give you one hint, choose where to start with monitoring. It's important. And last thing, a post-mortem. There is things that people have like a blaming. We blame each other. So in Wix, we used to have many downtimes, and we still have problems. We deploy a version, we have a problem, we have data corruption, database, all this stuff. We have problems. This is nature. We do changes, we're evolving, we have problems. But for every other problem, we do a post-mortem. We go together in a room, and it's important not to have blaming culture. That the person can talk about his problem without fear that he's going to be fired or put him like he's not a good developer and so on. Take away the blaming and talk about. But one more thing, side effect for this process. One more side effect is people learn. Every time we sit in a room, like 5 or 6 or 8 people, talk about problems, not only we get action items, how to prevent it next time, but by talking, we learn. And microservices is ecosystem. It's your ecosystem. You have your own standards. So you should talk about failures, because failure happens. And no one can tell you that no failure not happen. Microservices is not like a magic. Okay, I'm doing everything working. No. It has problem. We should talk about failures all the time. And we need to start from some point. So let's do it. And questions, if you have, I will be happy to throw this box. Questions? No question? Come on. I have the box.
You want to throw one?
Yeah, of course.
Do it.
Oh, please.
So, can you, yeah. Sorry. The question is, how do you structure your microservices? You said you have around 200 microservices running. Do you do anything to cluster them, to have, I don't know, cyclic free structures between them, or just arbitrary, any microservice can connect to any other microservice?
Okay, if I understand correctly, you want to know how they talk to each other?
No, not how they talk to each other. I think it's REST interfaces or something, or some lightweight queuing, but Do you manage the dependencies somehow between your microservices, or do you just don't care? Any one of these 200 can access anyone else of these 200?
Yes. Each service is trusted boundary of other service. So we use RPC. It's like RPC above HTTP. And in the RPC, we pass a signature that we sign the request. So for us, it's important. Everyone can talk to anyone because you want to be evolving. You don't want to stop. I have service, you can use it. I don't care. We're like startup. I want to change it, you break, you change your code. So we don't have any limitation. And people also think, let's do permission and so on. We don't agree. If your service is in Wix, you are trusted boundary. You can do whatever you want. But if something comes from the internet, then we have permission and so on. But within the services, everything permitted to anyone. Okay. Make sense? Mm-hmm. More questions? Yes, please. Can you pass? Sorry. Here. Yes, please.
So in a meetup a few nights ago, we were discussing similar topics. And something that we were not sure about is, imagine that two of your microservices use, let's say, the same structure. Let's say a person, a class.
Yes.
So this class has methods, and maybe it can be translated into, serialized into JSON, whatever. We could not agree on whether you should sort of take this class out, maybe put it in a common library, put this on your internal Maven-like repository, and then have both microservices linked to it. Or maybe you shouldn't do this, because then you are sort of effectively creating a dependency between these two. So what's your take on this?
It's a good question. I'll tell you what we do in Wix. So we're using JSON RPC, but on top of it, we have abstraction layer. We're using JDK proxy to call like a function. So we take, every time you want to have a service invocation, you said, I want interface of class user. And I invoke it. So effectively, a project have a jar API. So the service that consume this project depend on it on binary compatibility. And it helps us if you change, it helps us to break when in CI. So yes, we do have compatibility between services on a jar of an API, only of classes, of Java or whatever. I saw a presentation, someone called it distributed monolith. But I think I like this approach because I think the winning is that you want to be break on build time and not on production. Make sense?
Yeah.
More questions? More question? Yes, please. Yeah.
I have a question about sharing same information between microservices. For example, you have user information, which is probably useful in many services. How do you handle those things? How do you?
I just asked the question, but for this specific, in Wix we have user service. The other service depend on it. So every service has its own domain. So the user service, other services depend on it. Make sense?
Right. I think it makes sense that I understand the previous question is more about structure, about class, but what I see here is a real dependency. And typically in microservices, you don't want to have a service really dependent on another service, which means that if that dependent service is died, then your microservice more or less is unusable. So.
Okay, this is a different topic. You don't want to be dependent on the runtime, so if it's break, you can have actions to, let's say you want to get from your recommendation system a recommendation for your service. You can say, if it's failed, I don't care. But you can be, as I believe, you can be dependent on a domain in a build time. It's okay, you have a class, you can depend on it. But in production, you need to depend on the SLA. You say, this service has low SLA. So when I call it, I can ignore. If it's fail, I can have the default values to return. Or in some cases, I said, if I don't get the answer, I want to fail. I want to tell the customer, come later, and so on. Okay. More questions? Okay, it's been, yeah, one more. Been fun to be here. Thank you very much for the time. Thank you.